Okay, so section 13.2 notes, we're going to be going over z-scores, how to use those to find probabilities, and then we're going to be using it for word problems. For this, if you haven't already grabbed the pink paper with the z-scores on it, make sure you grab that. You will need that for these problems. Just a heads up, you can write on the paper that you are given for the z-scores today. You will be given a new one for the test that is blank with all of the numbers on there. So feel free to write on it as you need. And then the first part, I already have a typo. This shouldn't say S-score, it should say Z-score. So if you could change that on your notes, that would be perfect. For z-score, there is a formula that you are going to be using to calculate the z-value. So that z is going to be equal to x minus mu over our standard deviation. So for the variables, z, that is going to be our z-score. That's what it stands for. And that is going to be used to find the probability on that table that you got. All right. Then we have our mu, that stands for the average. Sometimes they're going to give you the average. Sometimes they'll ask you to find the average for it. That is what it's going to represent. Then just like with our normal distribution curve, we have our standard deviation. And then x, that is going to represent an outcome of a person, so, or an event. So if they give you the average test scores and they say this person scored a 60%, calculate the probability or their z-score for that event occurring. So x is a single event that we are comparing. Again, that value might be given to you or you might be asked to find it. This equation is something that you will need to have memorized for the test. So if you don't have it memorized, this is going to be a very hard test for you to complete because a lot of the problems are able to be completed using this method. All right, so our first example, we're going to use the z-score table to help us with this, and it's telling us a certain brand of light bulbs lasts on average 1,200 hours with a standard deviation of 100 hours. Assuming the bulb lifetimes are normally distributed, find the percentage of bulbs with the given lifetimes. So we have a visual of what we are working with. I'm just going to draw a sketch of a normal curve. We are not going to fill in everything. We're going to draw the normal curve. We know the average goes in the middle, which was at 1,200 hours, and the standard deviation was 100. So if we were to add more values, we would have 1,100 on the left and then 1,300 on the right. We're going to see what part of our table we are using. So all of the curve together is going to add up to 1 when we find the probability underneath the curve. So if we look at example A, for this one, we want less than 1,050 hours. And if we look 1,050 hours, that would not be one of the values we would have if we used the bell curve with the standard deviations of taking away 1, 2, and 3 of them. So because of that, we're going to use z-scores so we can get an accurate answer for this, because we know it would be somewhere around here. And we would need the probability of everything leading up to that. So we're going to find our z-score first using our equation that we just went over. Z equals x minus the average over the standard deviation. So they're telling us that this light bulb is going to have an average of less than 1,050 hours. That's our x value. Then in the problem, it told us that the average was 1,200 and the standard deviation was 100. So now we have all of those numbers to plug into our equation. So we would have 1,050 minus 1,200 divided by our standard deviation of 100. Now, when you type this into your calculator, you either need to use the fraction button or type in the top part, hit enter, and then divide by the denominator. All right, so if we clear this, so if you grab your calculator, you can do the alpha y equals to get the fraction, and then you can type in the 1,050 minus the 1,200 over 100. Or you could type it in, because we do want the decimal answer, not the fraction. You could type it in as 1,050 in parentheses minus the 1,200 divided by 100. If you type it in without parentheses, you are going to notice you are going to get the wrong answer. And also, it's going to be a number that's nowhere close to the z values on our table. So if you get a number that's not showing up on your z table under z, it means you typed it in wrong or you set up your equation incorrectly. So those are all the different ways that you could do it, and we should get negative 1.5 for our answer. So z equals negative 1.5. Now, remember, the z value is used to find the probability from our tables. That's not your final answer. So z is not your final answer on this one. So you're going to go to your table, and it was negative 1.5. So that means we are on the left side of our curve, which makes sense because we were going up to the 1,050 hours for the light bulb. Because we're on the left side, we just need to know what the z-score probability is that they would give us. And right now, for this one, our probability, or our z-score was negative 1.5. So I'm going to find negative 1.5 on my table. There we go. It's down here. And it didn't have anything after the negative 1.5, so that means it's just going to be the first value that shows up. 0.0668. So once we find that on our table, we're going to go back and write it down. So the probability for that event occurring would be 0.0668. That would be our final answer. So the likelihood of our light bulb lasting less than that many hours isn't very high. If we set it as a percentage, which would also be acceptable, you would have 6.68%. So not very many of them last less than that many hours, which seems like a pretty good deal. Okay, now we're going to look at our next one. For this one, they want between the hours of 1,100 and 1,300. So this time we have two different x values, which means you have to find the z-score for both of them. Because right now, let's use different color, we want the probability, and when we find our z-score, it's going to give us the probability up to the 1,100. And then when we find the z-score for 1,300 and find the probability of that, it's going to give us the probability of all the way up to that value, which means because we only want the part in between them, we're going to take the probability of the 1,300 minus the probability of 1,100, because that will leave us with just the probability of our middle space. So these ones are a little bit longer because you have to do multiple of them. So let's start with our 1,100. So z would be equal to 1,100 minus our average, which is the same as last time, 1,200, didn't change, divided by 100. Then again, you would type that into your calculator. We went over that on the previous problem, so if you need to go back, you can. This one would give us a z-score of -1. So we're going to go to our z table and find out what that probability would be. So I'm going to go to -1. It didn't have anything after the -1, so it's just our first number, 0.1587. Okay, so that's the probability of up to the 1,100. Now we're going to find the probability of up to 1,300 hours. And our average didn't change from last time. Our standard deviation is still the same. You would go ahead, type that into your calculator to figure out the value. And this time we would get +1. And we're going to use that to find the probability from our z-scores. So far, all of our z-scores have been negative, so we've used the same side of our paper. But now we need to flip it over to the positive side of our paper. So again, this is giving us all the probability up to that point. And our value for z was just +1. So we're going to find the +1, which is right here. And there was nothing after the 1, so we're going to take the first probability that shows up after it, 0.8413. Okay. So again, we found the probability of up to each of those hours. So we're going to take the probability of getting 1,300 hours, the 0.8413. That's all of this together. And then we are going to subtract the probability up to the 100. That way we are left with only the probability of the part in the middle between those two. So to get our final answer for this, for our probability, we're going to take 0.8413 minus the 0.1587. Oops, sorry. And that will give us our answer for this question. And again, you can type that right into your calculator. You get the calculator for the whole test. This one will be 0.6826. That is your answer. Perfect. Okay, now let's move on to the next one. This one is at least 1,350 hours. So if we look at our curve to help us figure out what we need to find, at least means that we're looking for the values that are more than this, more than 1,350. So the 1,350 would be somewhere over here. We need to find the probability that's on this side. We know all of the values together, the probability would end up adding up to 1. And when we use our 1,350 as x to find our z-score, that will give us the probability of everything up to that point. So to figure out what the probability of more than that would be, we're going to have to take 1 and then subtract the probability of everything that's in the blue. So anytime you're looking for the probability of an event on the right side, you're going to take 1 minus that probability. The rest of the steps are the exact same. So we're going to find our z-score first. Z is going to be equal to our x value of 1,350 minus the average, 1,200, over 100. Type that into your calculator. Make sure you type it in the correct way. This one, when you type it in and we want the decimal number, we would get 1.5. If you didn't get that, make sure you go back and watch the first example, A, on how to type it into the calculator correctly. Okay, so then we'll go to our z-score table. This one's positive, so make sure you go to the positive side. And the z-score was 1.5, so I'm going to go down until I find 1.5. There was nothing after the 5, so we're just going to take the first value in our table, 0.9332. So our probability of up to that many hours was 0.9332. Sorry. Let me double check that. Yes, positive 1.5. There we go. Okay, 0.9332. Sorry about that. Okay, so then to find the probability of getting more than that, because right now this is the probability of less than the 1350 hours. We want the probability of more than that. So to do that, we are going to take 1 minus the 0.9332. And that will tell us the probability of it getting more than that number of hours. So for that, it would be 0.0668. And that makes sense that this one is so small because it's just a little tail at the end of our chart. It's not a huge portion of it. All right, so that is example 1. Go ahead, if you feel like you're comfortable with this, you can skip the next video of example 2 and move on to example 3. If this was confusing and you want to try a problem on your own, go ahead, do example 2, and then watch the next video to check your answers.